Here we have a similar question to before, 3 equations, and this time we're showing that when A doesn't equal 3, there's a unique solution, and then finding B such that when A equals 3, there are infinitely many solutions. So writing this system of equations in matrix form. So for there to be a unique solution, the determinant can't equal 0. And then we found the determinant, and that just equals 3 minus A. And you can see that that will only equal 0 when 3 equals A. And so the determinant doesn't equal 0 when A doesn't equal 3. And that's the first part of the question done. For the second part of the question, we're going to let A equal 3. And that's what the system of equations looks like with A equal to 3. And now we're going to show that the bottom equation, the one with B in it, is actually the same as a combination of the top two equations. And how we're going to do that is we're going to show that it's the same as the top equation when you subtract the second equation away from it. And this is a technique known as row reduction, where you can add rows to each other, take them away from each other, whatever you like. So let's give this a go. So as you can see, we've just taken the third row and subtracted the second row from the third row, and the first two rows of our matrix system are still the same. And now you can see that row 1 is nearly the same as row 3. And now we ask ourselves the question, what is B so that row 1 equals row 3? And the answer is, if B equals 10, then row 1 equals row 3. And that's the end of that question. So just to review this question, for there to be infinitely many solutions, we want the determinant to be 0, and we want one of the lines to be made up of a linear combination of the other two lines. So in this case, having A equal to 3 makes the determinant 0, and having B equal to 10 gives us that one of the lines is a linear combination of the other two lines. And in this case, the linear combination is row 3 minus row 2 equals row 1, or that equation 1 is equal to equation 3 minus equation 2. And I know it's not in the question, but if you wanted no solution, then your condition would be that A equals 3, but B doesn't equal 10. And this is because you want the determinant to be 0 in the case of no solution, which is given by A being 3, but you don't want a linear combination, so you don't want B to be equal to 10. And as we said earlier, for there to be a unique solution, you want the determinant not to equal 0, and so you want A to not equal 3.